Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy. But next we have a fun problem, and I say that truly honestly. So far we have not been solving for plus c, because normally we don't need to. However, it's possible that we can solve for it, especially if the question's essentially implying that they want you to solve for it. What do I mean by that? Let's say this problem. I have f prime of x, I'm going to give you the derivative, is equal to x to the fifth minus 6x plus 2 all divided by 2. Then I'm also going to give you the point f of negative 1 equals 4. Notice this is not the derivative, this is the original function. And what I want you to do is I want you to find what f of x is equal to for this function. So one of the most important things to realize for, well, derivatives and integrals, if I give you the derivative, then how do I find the original function? That's why we have the integral. So what I'm asking is, what's the integral of x to the fifth minus 6x plus 2 divided by 2, and let's find this integral first. So the first thing I'm going to do is with this divided by 2, again, this is not a quotient rule. We don't have quotient rule in integrals. Instead, I'm going to treat this like a 1/2 all the way out in front. So it's like 1/2 times the integral of x to the fifth minus 6x plus 2. Need to put that in parentheses, dx. And again, it's a 1/2 out in front because that 2 in the denominator is essentially just a big 1/2 to all those terms. So now I can take this integral. It's not too bad. 1/2 times x to the fifth, well, that's now going to be plus 1, so x to the sixth over 6. Hopefully you're getting the hang of it now. I can start to go a little bit faster. Okay, the next one's kind of annoying actually, but this minus 6, that's just a coefficient. I'm going to write it out in front. And then the integral of x is, well, if that's x to the first power, that's going to be x squared over 2. I can simplify that in the next step. And then what's the integral of plus 2? Well, remember, there's no x there, which means for the integral we just add an x, it's 2x. And then, of course, we have plus c. Oh, and I need to be careful here. So pretty much where does the end parenthesis go? It's going to go right here. In other words, this 1/2 is being applied to everything except plus c, because the plus c goes at the very end. Okay. This can simplify a little bit. I'm going to also distribute the 1/2 to every term at this point. It's not too bad. So I'm saying here I have x to the 6th divided by 12, because 2 times 6 is 12, minus, notice here I have 6 divided by 2, which is 3, but then I'm still dividing by 2, so 3/2 x squared plus 2 times, actually, 2x divided by 2 is now just x, so that's easy, and then plus c. Okay, great. We have our equation for f of x. Only one problem, the plus c, we don't want it. And the reason we don't want it is because I gave us an initial point. F of negative 1 equals 4. In other words, negative 1 is our x point, 4 is our y point. We can just plug this into the equation, solve for c, and let's see what we get here. So in other words, I'm saying I'm plugging 4 in on the left and negative 1 in for x. So it's going to be negative 1 to the 6th divided by 12 minus 3/2 times negative 1 squared plus negative 1 plus c, and again that equals 4. This is not going to be friendly numbers. I don't know why I did this problem, but it's not that bad. Negative 1 to the 6th is now positive 1/12 minus 3/2 times negative 1 squared would just be 3/2 times positive 1 now, so it's still minus 3/2. Then minus 1 plus c. This isn't too bad. Let's get a common denominator of 12. So on the left, 4 times 12 is 48. Is that right? Yeah, 48/12 is equal to 1/12 minus 3/2. We need a common denominator of 12, so I'm multiplying by 6 over 6. 3 times 6 is 18 over 12, minus 1 is the same thing as 12/12, and then plus c. This is not very friendly. Do I want a calculator? No, we don't need it. So 48/12 is equal to, on the right, 1 minus 18 is negative 17. Minus another 12 is negative 29 over 12 plus c. Now I just need to add 29/12 to both sides. So 48 plus 29 is 60, 77/12. That's c. Okay, great. Now the last step you need to do is just write out the full equation. F of x is equal to my original function, which was what? X to the 6 over 12 minus 3 halves x squared plus x plus c, and we're plugging in c with 77 over 12. So x to the 6th over 6 minus 3 halves x squared plus x, and then plus 77 over 12. That was a mouthful, but there you go. There you go. That problem wasn't too bad. Honestly, if I were to do it again, I wouldn't have chosen such ridiculous numbers, but the lesson is still the same. The way we solved this problem is we took the integral, then to solve for c, we had to use our initial point, which in this case was the point f of -1 equals 4. The x point was -1, the y point was 4. Any questions on this one?
How'd you get 48 over 12?
That's because so at this step, I did what's 12 times 12, I asked myself to get the common denominator, and 12 times 4 is 48.
Oh, so wait, what were you trying to get the common denominator between the 4 and...
I was trying to get a common denominator between all of my terms. So like 4, -1 to the 6 over 12, 3 halves times -1 squared, and -1. The biggest common denominator would be 12.
So then you multiplied everything by that.
Exactly. And alternatively, you could just plug this in your calculator, and that's obviously what I would encourage you to do on the test. But I like mental math. I'm old-fashioned that way. I don't kiss before marriage. You know, that kind of stuff.
Okay, thank you.
Yep. Any other questions?
I have one question. How did you get the 12 in the denominator in the first place?
Yes, so that was back in this step right here. I distributed the 1/2 to every term. And where did the 1/2 come from? Right here in the original problem.
Okay, thank you.
Yep. Any other questions? Okay. Yeah, that was a hard problem. Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks everyone. Bye-bye.